Hello everyone. Welcome to my video. Today, we're talking about building management systems. Special thanks to Professor Dr. Yogesh Padiya for guiding us. So, without further delay, let's dive in and explore the exciting world of building management systems together. Here's the table of contents. Let's break down what we'll cover. Introduction to Building Management Systems, BMS. We'll start with a quick introduction. Next, we'll define what is BMS. Then, we'll explore the importance of BMS in HVAC system, followed by discussing the characteristics of BMS. After that, we'll look at the structure and components in BMS. Then, we'll highlight the features of BMS. Next, we'll talk about the benefits of BMS. Moving on to the advantages and disadvantages of BMS. Finally, we'll wrap up with a conclusion. Let's proceed step by step and explore building management systems together. In the introduction, we learn that all buildings require mechanical and electrical services to maintain comfort. Basic controls such as manual switches, time clocks, or temperature switches are commonly used. However, with the introduction of a building management system, BMS, we can ensure efficient control for a comfortable working environment. This highlights the significance of BMS in optimizing comfort conditions in buildings. Now, let's understand what exactly is a building management system. A building management system, or BMS, serves as a central controlling facility. It automates and takes control of various operations within a building. BMS manages all the systems and coordinates their functions seamlessly. Its primary objective is to provide a comfortable working environment in an efficient manner. Furthermore, BMS is designed to control, monitor, and optimize a wide range of building services. These services include lighting, heating and cooling, security, audiovisual and entertainment systems, ventilation and climate control, as well as time and attendance control and reporting. In essence, BMS plays a crucial role in ensuring the smooth operation and optimization of building services. Let's explore the importance of building management systems in optimizing HVAC systems and buildings. Firstly, BMS plays a crucial role in energy efficiency by precisely controlling and optimizing HVAC systems. This reduces energy waste and lowers utility costs by adjusting settings in real time based on energy usage monitoring. Secondly, BMS leads to cost savings over time. By identifying areas of inefficiency and suggesting improvements, it significantly reduces operational expenses and increases profitability for building owners. Thirdly, BMS provides remote monitoring and control capabilities. This allows building managers to monitor and adjust HVAC systems remotely, ensuring optimal performance whether on-site or off-site, providing flexibility and convenience. Lastly, BMS ensures improved comfort for occupants by maintaining optimal temperature, humidity, and air quality levels. This continuous monitoring and adjustment create a comfortable indoor environment, enhancing productivity and satisfaction among building occupants. In summary, building management systems are essential for optimizing HVAC systems and enhancing the overall efficiency and comfort of buildings. Now, let's explore the defining characteristics of building management systems. To begin, building management systems are most commonly implemented in large projects with extensive mechanical, electrical, and plumbing systems. Additionally, systems linked to a BMS typically account for a significant portion, around 40% of a building's energy usage. When including lighting, this number rises to about 70%. However, it's crucial to highlight that improper installation can lead to system malfunction and energy wastage. Lastly, let's discuss the four fundamental functions of a central, computer-controlled BMS: controlling, monitoring, optimizing, reporting. These functions are essential for ensuring the efficient operation and management of building systems. Let's take a closer look at the components of building management systems. In general, the term BMS encompasses all control elements, including hardware, software, controllers, linking networks, and central controllers. A building management system typically consists of three main components. 1. Field layer level. Field device. This includes sensors and actuators placed throughout the building to monitor and control various parameters such as temperature, humidity, and lighting. 2. Automation layer level. DDC controller. This layer consists of direct digital control, DDC, controllers, which receive input from the field devices, process the data, and execute control actions based on predefined algorithms. 3. Management level, centralized workstation. At this level, a centralized workstation serves as the brain of the BMS, providing a user interface for building operators to monitor system performance, adjust settings, and generate reports. Together, these components work seamlessly to ensure efficient control and management of building systems. The field layer level, which comprises field devices. At the field layer level, field controllers play a crucial role. These controllers receive signals or stimuli from the environment through sensors, meters, switches, or valves. They collect information from these devices and transfer it to the next stage, which is the automation layer or DDC controller. Essentially, field controllers act as the frontline data gatherers, collecting vital information from the building's environment to be processed further by the BMS. Now, let's take a closer look at the components that make up building management systems, BMS. These components work together to ensure efficient operation and management of building systems. Damper actuators. These control airflow by adjusting the position of dampers in ventilation systems. Valve actuators. They regulate fluid flow in HVAC systems by controlling valves. Chillers, boilers, cooling towers provide heating or cooling for the building's HVAC system. Variable speed drives, VSD, adjust motor speed in equipment like pumps and fans to match demand, saving energy. Pumps, fans, motors. These components move fluids throughout the building for HVAC and other systems. Airflows, pressures. Sensors measure airflow rates and pressures to ensure proper ventilation and system performance. Water flows, pressures. Monitor water flow rates and pressures in plumbing systems for efficient usage. Voltages, currents. Measure electrical parameters to monitor and control power usage. Temperature, relative humidity, CO2 sensors. Provide data on environmental conditions for HVAC control and occupant comfort. Low-level and high-level, HLI, connections. Interface between field devices and higher-level control systems. Fire and smoke detectors. Detect fire or smoke presence, triggering alarms for safety. Access control systems. Regulate entry to the building or specific areas, enhancing security. Surveillance cameras. Monitor activity indoors and outdoors for security purposes. These components form the backbone of a building management system, ensuring efficient operation and safety within the building. Automation layer level, which is typically managed by a DDC controller. The automation layer, overseen by the DDC controller, is responsible for running and communication functions within the building management system. When data is received from the field layer, the DDC controller transmits it to an interface, often a web browser, capable of displaying all relevant information. Key characteristics of this component include being microprocessor-based, pre-configured or freely programmable, and tasked with controlling the HVAC equipment of the building. Essentially, the DDC controller serves as the intermediary between the field layer and the management level, ensuring seamless data transmission and control functionality. Let's now explore the management level, which is represented by the centralized workstation. The management level offers a unified view of all systems through the Open Building Operating System (BOS) platform. Within this level, various systems such as cooling, ventilation, lighting controls, consumption measurements, access controls, intruder alarms, and fire alarms are seamlessly integrated with the BOS using device drivers. This integration ensures that building operators have a comprehensive and centralized platform to monitor and manage all aspects of building operations. In essence, the management level serves as the command center, providing operators with the tools they need to maintain optimal performance and safety throughout the building. Here's the key features that make building management systems so useful, so let's go one by one. 1. Easy control. These systems are designed to be user-friendly, allowing anyone to adjust settings and manage building functions easily. 2. Security. With features like access control, surveillance, and alarms, BMS keeps buildings safe from unauthorized access and intruders. 3. Heating and cooling management. BMS efficiently controls HVAC systems to maintain comfortable indoor temperatures while saving energy. 4. Heat control. Beyond HVAC, BMS regulates internal heat sources to maintain consistent temperatures and avoid discomfort. 5. Lighting control. BMS optimizes lighting usage based on occupancy and natural light, saving energy and enhancing comfort. 6. Electricity management. Monitoring and managing electricity consumption helps reduce waste and lower utility costs. 7. Ventilation. BMS ensures proper airflow and indoor air quality, creating a healthy environment for occupants. 8. Water management. Efficient management of water resources helps conserve water and prevent wastage. 9. Fire alarms. BMS detects and responds to fire hazards promptly, protecting occupants and minimizing damage during emergencies. These features work together to make buildings safer, more comfortable, and easier to manage, improving overall efficiency and functionality. Let's see how building management systems benefit us. 1. Room control. You can adjust each room to your liking, making everyone comfortable. 2. Saving energy. It helps us use energy wisely, saving money and helping the environment. 3. Reliability. Things break less often, so we save time and money on repairs. 4. Quick fixes. Problems with heating or cooling get fixed fast, so we're always comfortable. 5. Saving time and money. Maintenance is easier and cheaper, so we can focus on other things. 6. Smart sensors. Lights and heating adjust automatically, saving energy when nobody's around. 7. Better lighting. Lights turn off when not needed, saving even more energy. 8. Water and energy savings. It helps us use water and energy wisely, which is good for our planet. These benefits make buildings nicer to live and work in, while also helping the planet. More energy. 8. Water and energy savings. It helps us use water and energy wisely, which is good for our planet. These benefits make buildings nicer to live and work in, while also helping the planet. Now we are going to see advantages and disadvantages of building management systems. Advantages. 1. Higher levels of security and safety. Building management systems enhance security measures, ensuring a safer environment for occupants. 2. Simplified operation. Users and administrators find it easier to operate and manage building systems with BMS. 3. Simpler staff tracking. BMS facilitates efficient tracking of staff movements within the building, improving management processes. 4. Reduced administration costs. BMS streamlines administrative tasks, leading to cost savings. 5. Infrastructure cost reduction. By sharing infrastructure, BMS helps reduce overall system costs. 6. Customized information delivery. Information can be delivered to all interested parties in the format and manner they need, enhancing communication and decision-making. Disadvantages. 1. Increased system complexity. Implementing BMS adds complexity to building systems, requiring careful management and maintenance. 2. Initial cost and additional cooling system expenses. The upfront cost of implementing BMS, along with the cost of installing cooling systems for computers, can be significant. 3. Shorter lifespan compared to traditional buildings. Intelligent buildings may have a shorter lifespan compared to traditional ones due to technological advancements. 4. Need for trained staff. Operating and maintaining BMS requires trained personnel, adding to operational requirements. Considering these factors can help us make informed decisions about implementing building management systems in our buildings. In conclusion, building management systems, BMS, play a vital role in controlling energy usage within buildings, optimizing both thermal and lighting efficiency to drive cost reductions. Despite the initial expense, the growing demand for BMS is anticipated to make them more attainable over time. This accessibility will lead to improved productivity and sustainability in workplaces. By embracing BMS technology, organizations can create more efficient and comfortable environments while also contributing to long-term cost savings and environmental stewardship. Thank you for joining me on this journey through building management systems. If you have any questions, please comment down and like, share, and subscribe our channel.